Hello everyone, this is Ketish here. In this video, I'm going to go through question number 3 from the AQA 2022 Physics Paper 1 Foundation tier. This question is on the topic of atomic structure. A teacher demonstrated that the radioactive isotope americium 241 emits alpha particles. Figure 4 shows the equipment used. So here you have the radioactive source on one side and a radiation detector, and the radiation detector is usually called a GM tube. So a GM tube, you don't actually call it a radiation detector properly. The proper name is a GM tube or Geiger-Müller tube. They do ask question what is the name of this radiation detector. So question 3.1, an americium nucleus emits an alpha particle. If it's emitting an alpha particle and turns into neptunium nucleus, which is the correct nuclear equation for this decay? So you can see at the start americium, it's actually the same. So americium AM 241 and 95. So this 241 is the mass number and this 95 is the proton number. So that's the mass number and this bottom number is the proton number. Now, in order to find out which is the correct, you need to know what is an alpha particle. An alpha particle is a helium nucleus. So that's why you've got He on all three of them. The helium nucleus has a mass of 4 and a proton number of 2. So helium nucleus has two protons and 2 neutrons. That's why the mass is 4 when you add these two up together. Now, the mass number should be equal on both sides. So you have 241 should be equal to 237 plus 4, right? That would be 241. 93 plus 2 is 95. So the first option is correct. Now, here 245 is way more than 241. So these two numbers don't add up. So that's incorrect. And the third one, 237 plus 4 gives you 241. But the bottom proton number is incorrect because 97 plus 2 is 99. It doesn't add up to 95. What is the furthest distance the alpha radiation can travel in air? Now, what is the furthest distance an alpha particle can travel? Now, alpha particles don't travel a lot. So, a few millimeters, no. A few centimeters, yes. A few meters, that's usually gamma. So, alpha particles travel a few centimeters. Question 3.3. The teacher placed a piece of paper between the americium and the radiation detector. The reading on the counter rate meter decreased by a large amount. Why does the decreased reading show that americium emits alpha radiation? Now, if you go back to this diagram, if you place a paper in between, and if the reading actually drops by a large amount, that means that the paper is actually stopping the americium from going through into the radiation detector. So, going back to our question again, the reading on the count rate meter decreased by a large amount. Why does the decreased reading show that the americium emits alpha radiation? paper stops alpha radiation. Right? Paper stops all types of radiation. That's not true. Beta and gamma can go through. Paper stops beta and gamma radiation. Keep saying Peter. Paper stops beta and gamma. No, it doesn't. It'll actually go through. The teacher replaced the americium-241 with a source of beta radiation. Now they're replacing it with a beta radiation source. Which symbol represents a beta particle? Now, you have to remember that a beta particle is a fast moving electron. Hence, you've got E to show electron. Now, the mass of the electron is 0. So, the top number has to be 0, right? So, it has to be either one of the first two boxes. Now, the charge of an electron is -1, right? So, the proton number, right, that has to be negative. So, it is the first box. Next question, 3.5. The count rate from the source was 119 plus or minus 7 counts per second. Calculate the smallest count rate that could have been. So the smallest count rate that could have been is 119 minus 7. That would give you 112. Right? The highest would actually, you would add the 7 to this 119. So that's 112. A teacher investigated how the distance between a different radioactive source and the detector affects the count rate. Question 3.6. Draw one line from each type of variable to the description. So you are meant to draw only one line from each type of variable here. So draw one line from each type of variable. So the control variable, right? So what they are, if you look back in the question, a teacher investigated how the distance from a different radioactive source and the detector affects the count rate. So how is the distance, right? Which means that they have to change the distance. That would be my independent variable. I'm choosing to change the distance from a different radioactive source. Now, you wouldn't be changing the radioactive source while you're doing the experiment in between. So that should be your control variable. And the detector affects the count rate. Right? Count rate depends on the distance. So that would mean that is your dependent variable. So your control variable is the radioactive source. Dependent variable is the count rate. The independent variable is the distance between the source and the detector. Question 3.7. Figure 5 shows how the count rate from different radioactive source changed with the distance from the source. So here you have the count rate starting at nearly 60, and then as the distance from the source in centimeters is increasing at the bottom on the x-axis, the count rate is actually going down really fast. And by the time it reaches nearly 40 here, it's actually nearly 0. Describe the relationship between the distance from the source and the count rate. So the keyword is for you to describe, and it's out of 2 marks here. So you need to say at least 2 points. So what is actually happening? Describe the relationship between the distance from the source and the count rate. So you have to compare what's happening, the y-axis and the x-axis. So as the distance increases, right? So from 0 or nearly 5, as the distance increases from 5 centimeters to 7 centimeters, what is happening to the count rate? The count rate is actually going down. And the second point you can say is by the time it reaches to about 40, the count rate is nearly 0. So here's a model answer. Let me make that slightly bigger. There you go. As distance increases, the count rate decreases. Between 0 and 50 centimeters, the count rate becomes 0. That's your second mark. So you can write your answers in bullet points. So as distance increases, the count rate decreases with 1 mark. Between 40 and 50 centimeter, the count rate becomes 0 is your second mark. That brings us to the end of question number 3, and I will see you in question number 4.